All right, here we go. We are continuing with section 13.1, and we'll call it part 2. Part 2. How's that? All right, so I think the last thing let's just review real briefly here. I think the last thing that we did, we were able to figure out what this sine, cosine, and tangent of 45 degrees is without using a calculator. And they're exact values. They're not approximate values, all right? So what did we do? We made the hypotenuse 1, didn't we? And then, remember, if this is 45 degrees, we said that the hypotenuse is the square root of 2 times the leg. So if I know the hypotenuse, I want to find the leg, what would I do? I wouldn't multiply by square root of 2. I would what? I would divide by the square root of 2. Then we simplified this thing by rationalizing the denominator. Remember that phrase? That's when you get rid of the square root in the bottom. Okay, multiply both top and bottom by square root of 2, and that eventually gave us what? Square root of 2 over 2. And that's one of those kind of famous numbers that you should memorize. All right, square root of 2 over 2 is one of those big time numbers that should just like roll off the tip of your tongue. All right, square root of 2 over 2. That's the side of both of these. That's both of the sides. Because if it's 45, 45, these two sides have to be equal to each other. Would you agree? So if this is square root of 2, this has got to be square root of 2. All right, so what we did yesterday, we figured out what the sine, cosine, and tangent is of those angles, 45, 45. All right, let's see. Oh, you're out 2 places? But I'm just writing the third period, right? All right, have fun. Don't crash into my car. The one that you're not going to run into. All right, so let's see. We're going to do a sine of 45 degrees, cosine of 45 degrees, and the tangent of 45 degrees. Everybody with me so far? You should be able to walk down the hallway, somebody tap you on the shoulder and say, what's the cosine of 45 degrees? And you should be able to tell them without pulling out the calculator. Square root of 2 over 2. Very good. So watch. It doesn't matter which 45 you use, does it? Let's use this one. So the sine is opposite over hypotenuse. So the opposite is square root of 2 over 2 over the hypotenuse, which is 1, which makes it real nice and easy. So it's just the square root of 2 over 2. All right, and if you put it into a calculator and put in the square root of 2 over 2, it's like 0.707 something. The sine of 45 is exactly the same thing, exactly, number for number. And so you know that they are equal. The cosine is the same exact thing because it's adjacent over hypotenuse. The adjacent is the same thing as the opposite was, so that's also the square root of 2 over 2. All right? And that's kind of interesting. Now the tangent. The tangent is the opposite over the adjacent. This is the opposite. This is the adjacent. So it's a number over itself, isn't it? So what's anything divided by itself? It's 1, correct. So that's the sine, cosine, and tangent of 45 degrees. So you have it memorized. You should have it memorized. You really should.
So is that kind of like a theorem or something? Like
it's not really a theorem. It's just a special triangle. It's something that's nice to know about a special triangle.
Give us a question like, what is the sine of 45? Like we wouldn't have to do any math. We just write it.
Right, exactly. But you could, if you didn't remember and you didn't have a calculator on you, you could always figure it out from all this stuff. Okay. The question that people usually ask is, why did you make the hypotenuse 1? Remember yesterday I said don't worry about it that much? But let's make the hypotenuse something else. Let's make it like 5. You still get the same. And I just want to show you that you will get the same. We'll just do it real quick. Okay, so if this is 5, what would this be? This would be 5 divided by the square root of 2, correct? If you rationalize the denominator, you would get 5 square root of 2 over 2. And this would be 5 square root of 2 over 2. All right, so you look at it and you're like, wait a minute, the sine is this. But that's 5 square root of 2, that's square root of 2 over 2, or right here. Is it the same thing? Well, remember, it's over the hypotenuse, isn't it? The opposite over the hypotenuse. So it would be 5 square root of 2 over 2, what? Over 5. You see that? Right. So, or you could look at it like this. Divided by 5 is the same thing as multiplied by 1/5, right? You see that? So that 5 and that 5 go, and sure enough, it still comes down to the square root of 2 over 2. So it really doesn't matter that you made that a 1, did it? Just a lot easier, though, because when you took opposite over hypotenuse, the hypotenuse was a 1, and it made sense. I don't know. Yeah, we might get to it in this next lesson. I don't know. I haven't looked that closely. But there's a thing called a unit circle that's very important in trigonometry. All right. Unit means 1. All right. That's what unit means. So unit means 1. So it's basically this. I really didn't mean to get into this, but I'll do it anyway. I'm not going to get real detailed, but I'll just show you a little bit. So if you had a circle, and let's say we'll put an x and a y axis in here. Let's try to line it up. Oh, that's not too bad. About right there, and then I'm going to have to scooch that thing over just a little bit. Oops, wrong way. Alright, that's pretty good. So watch this. A unit circle is a circle whose radius is what, do you think? It's called a unit circle. It's 1 unit. Okay, so from here to here, how far would that be? That's 1. Right. So if this is an x and y axis, which it is, coordinate plane, if that point right there, if the radius of this circle is 1, what's actually the ordered pair at this point? 1, 1. 1, 0. 1, 0. Okay? And I'll show you this. This is kind of, I don't know if they do this in another lesson. Let me just look. I don't know. I like teaching this, so maybe that's why I'm going through it. It doesn't look like... Oh, they do this, and when they do this in the next lesson. So we'll save that for the next lesson. Is that all right? Yeah. I just kind of get excited about this. So.
Do you like this better than geometry? Algebra 2 and stuff?
I probably would have to say yes. Even though I do like geometry, I like a lot of parts of geometry. There's some parts that I don't really care about, but yeah, Algebra 2. I think if I had a choice to teach either one, I'd probably choose Algebra 2. Let's see. All right, let's do this. Let's do an example here. Yeah, it's 30, 60. Oh yeah, we got to do 30, 60, 90. Right, I forgot about that. Wow, I went through the whole 45 thing. So there's 30, and there's 60, and there's 90. Again, we're going to make the hypotenuse 1. Right? You can make it anything, but it's a lot easier if you make it 1. Again, it's because of the unit circle. The radius of the circle would be 1. All right. I'm not going to get really into this, but watch. I got to get back to this because look, it's a unit circle, right? So if I drew that blue is also 1, isn't it? And so is this one down here. Can't really see it too well, but there's a little blue line down here. Yep, that's 1 as well. But watch this. If I drop this thing down like that, and let's say this was a 30-degree angle right there, then what is the hypotenuse? It's 1, isn't it? Right? That's because it's a unit circle. You see that? So if I make a right triangle out of it, that's 30 degrees. That's 1. So what's this little one? Well, actually, we'll do that here in a second.
1 times.
So do you remember the relationship between this? I should have made this a little skinnier, but that's okay. Remember, this is the short side. This is the long side.
That one would be 2.
This would be 2? It would be half. Remember, the hypotenuse is 1. So the hypotenuse is twice the short side. Right? So 1 is twice as big as this. So this has to be a half. We're not going to use 0.5. We're using fractions. Okay? So it's 1/2. Try to get away from decimals when we do stuff like this.
Same thing with the circle thing. That's how we use 1/2 also.
That's correct. Yeah. And now, what about this right here? Yeah. So remember, it's the square root of 3 times the short side. So there's the short side times the square root of 3, right? But we write it a little cleaner than that. It looks a little sloppy, so we just multiply the top, which would be square root of 3 over what? 2. See how easy that is? So the short side's half of the hypotenuse, right? If the hypotenuse is 1, then the short side's got to be a half. The long side is the square root of 3 times the short side. We wrote that down yesterday. You can look in your notes. It's probably on your notes. All right? So that's the square root of 3 over 2. The cool thing about this is this stuff right here. The sine, let's do 30 degrees. And we'll do 60 in a second, but we'll do 30 first. So the sine of 30 degrees, the cosine of 30 degrees, and then the tangent of 30 degrees. We should be able to figure this out without using a calculator. Okay, we don't need a calculator for this. So let's take a look. What is the sine? The sine is opposite over hypotenuse. So the opposite is a half. What's the hypotenuse? It's 1. So what's the sine? It's 1/2 over 1, which is just a half. Try that in a calculator if you don't believe me. It's opposite over hypotenuse. Move this over. Okay, so this is opposite. This is the 30 degrees, so it's 1/2 over 1. 1/2 over 1 is just a half. Agreed? Okay. I just want to show you this as well, just so you can see that the calculator is telling you the truth. Watch, the sine of 30. Let's see if it actually is a half, like we said it should be. Look at that. That's a half. 0.5, but it's a half. It's kind of interesting, isn't it? Isn't that cool? But we did it without a calculator. Wasn't that nice? All right. Just by knowing your special right triangles. Remember we did that back in chapter 8, the 30, 60, 90. Okay, this is part of the reason why we did that stuff back then. What about the cosine? The cosine is the adjacent over the hypotenuse. So what's the adjacent? It's not negative. There's no negatives. Square root of 3 over 2 over 1, right?
Yeah,
but does the over 1 really do anything? No. That's why it's nice to have that a 1, because if that's your denominator, it's just what? Square root of 3 over 2. So that's the cosine of 30. If you don't believe me, let's try it. Let's do the cosine of 30. You're like, whoa. How do I know that's square root of 3 over 2? Well, let's punch in square root of 3 over 2 and see if it's the same number. Because you don't recognize that, do you? As a square root of 3 over, you definitely recognize that as half, but you don't recognize that. So let's put it in here. Square root of 3. So let's see, square root of 3 divided by 2. Let's see. Boom. Same exact number, isn't it? Exactly the same, all the way to the very end of it. All right. So would you agree square root of 3 over 2 is the same thing as cosine of 30? Yep, so we're not lying to you. What about the tangent of 30? The tangent of 30 is the opposite over the adjacent. Let's do a little work with this, though. So I've got the opposite, which is a half, over the adjacent, which is square root of 3 over 2. Let's simplify it, though. Instead of divide, what am I going to do? Multiply by the inverse or reciprocal. Okay? Everybody see that? Just multiply the right. What happens now when I multiply these together? 2's cancel out, and so I'm left with 1 divided by the square root of 3. I don't want to leave it like that because I haven't rationalized the denominator, so how am I going to write this? Should be able to do this in your head at this point, can't you? Multiply top and bottom by square root of 3, so what do we get? Yep, square root of 3 over 3. Good. So the tangent, all that work right there, the tangent of 30 degrees is equal to the square root of 3 over 3.
Now, I have a question. Would it work the same, like, with 45, 45, 90, you said that you can always change the number of the hypotenuse and it wouldn't matter?
Right.
Is it the same
Yep.
for this?
Same exact thing. Yep. I could make this anything. It's just that factor will cancel out eventually. Right? I just made it a 1 so I wouldn't have to worry about canceling anything out. But if this was, yeah, because this would be what? This wouldn't be a half then. If this was like a 5, this would be 5 over 2, wouldn't it? Right. And then this would be 5 square root of 3 over 2. So they would eventually cancel out anyway and boil down to this. But it's a lot easier making that a 1.
Okay.
We good? Yes, ma'am. That's fine. Let's take a look at the 60 degree. Let's do the 60 degree angle. All right, so let's do the sine of 60, the cosine of 60, and the tangent of 60. These are all special angles that eventually, not in here right now at this point, but eventually when you really start getting into this stuff, like in Algebra 2 and in pre-calculus, you'll do a lot of this kind of stuff. These things should be memorized. Again, you should be able to walk down the hallway, somebody tap you on the shoulder and say, tell me what the cosine of 60 is, and you should be able to tell them without even using a calculator. Okay? So let's take a look at let's do the sine of 60 first. So the sine would be what? It would be opposite over hypotenuse. So it'd be, right, so what's that going to be? Good, it's just the square root of 3 over 2. Notice, the sine of 60 is the same thing as the what? Cosine of 30, okay? We talked about that, I don't know if you remember, but we talked about that back in chapter 8. And then the cosine of 60 would be what? Adjacent over hypotenuse. So it's 1/2 over 1, which is just 1/2. Those are pretty easy because your hypotenuse was 1. What about the tangent, though? I've got opposite over adjacent. We'll basically do the same thing as we did right here. Or you could do this. Now, let's just do it the same way. Opposite over adjacent. So here's the 60. Which one is opposite this time? Square root of 3 over 2. Over the adjacent, which is 1/2. Let's simplify it. So it's square root of 3 over 2 times what? 2 over 1, right? Because multiplied by the reciprocal, the 2's cancel. We don't even have to rationalize the denominator on this one, do we? It's just the square root of 3.
Wait, but you did the tangent for 30.
Mm-hmm.
And you got 1 over square root of 3. I got lost. What did you do after that?
I multiplied the top and the bottom by the square root of 3. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is just 3. Okay? You didn't have to do that here because the square root was on the top. So you didn't have to worry about that. Like where? Right here?
Yeah.
Because, well, they would, but then you'd be left with what you started with. And then, see, they actually do cancel out, but then you're left with 1 over square root of 3, and it's like just going around in a circle, right? So I multiply straight across the top and bottom, and then it simplifies to this. We good? So those are some special, so if we wanted to list them, you already got them listed. I'm not going to write them all down again. But you've got sine, cosine, and tangent of 45 degrees. You should have memorized. Okay. You've got sine, cosine, and tangent of 30 degrees. You might not have it memorized right now, but eventually that should be something that's in your head. And then sine, cosine, and tangent of 60 degrees. So that's what? That's 9 special angles, isn't it? All right. And tomorrow we'll learn a few more. This is what I was going to get at. This angle right here would be 0 degrees. Then if you went up here, if I consider this to be 0 degrees, what would this angle right up here be? It'd be 90. And then what would this be? 180. And what would this be? 270. Okay. And then if I go back around the circle one more time, how many degrees would I get here? Right? So 0 degrees is the same place as 360, isn't it? You could keep going around the circle, around, but we'll just do it once. All right? So you're also, tomorrow, I'll leave this, give you a little suspense so that you look forward till tomorrow. You're also going to be able to figure out what the sine, cosine, and tangent of 0 degrees is. Sine, cosine, and tangent of 90. Sine, cosine, and tangent of 180. Of 270. All right? I know, you're dying to know, but you can twist my arm, and I'm not going to tell you until tomorrow. Okay? All right. Let's do a couple examples. We're being a little silly here, but yes, we're going to have a little worksheet. But let's do a couple examples. Oh, somebody really messed my clock up. Is that moved? I think somebody just messed with it. It's, what, 13 after? Okay, we got some time. Got like 15 minutes, right? Let's do this. Let's just do a couple of quick examples here. I'm just looking straight in the book. I know you don't have the book, but write them down. Put them in your notes. This is 8. This is 30 degrees, and this is x. Let's find. Now they say in the book, I wish they wouldn't do this. They say round to the nearest tenth if necessary, which means you could just use a calculator, but I want to do this without a calculator. So I'm going to change the problem, and I want to say find an exact value for x. I'm changing it. I want you to find the exact value for x. Yep. Okay. I want you. It's actually not harder. It's actually. I mean, you got to think. Yeah, you do have to think. I guess you could consider it harder. I don't know. But you're finding an exact value, right? Not a decimal approximation. And sometimes it's good to find that. To tell you the truth, most of the time, like in the real world situations, you're going to use a calculator and get approximations. But
Wait, on a worksheet though, are you going to use that value?
I don't know. I don't have it in front of me. But I might have you find the exact value. Just do whatever I tell you to do. Whether worksheet says it or not, I don't care. I'm the boss. So I'll tell you how I want it. All right, so the exact value for x. So how do we do that? Well, let's see what we got. What side is this to that 30 degree? That's adjacent. And then what is the 8? That's hypotenuse. So what trig function are we going to use? The cosine of 30 equals what? Right, adjacent over hypotenuse. And so we solve for x, multiply both sides by 8, correct? Now, at this point, you would have just put this into a calculator, but it's 30 degrees. All right, so we should know 30 degrees. Remember the cosine? Think about it. The cosine would be this one, so what would it be? What's the square root of 3 over 2? Right, so this is going to be 8 times the square root of 3 over 2, correct? And then you simplify it. The 2 goes once, the 2 goes 4 times. So what's x as an exact value? It's 4 square root of 3. Okay, see? Yeah. So, if you're stuck on a desert island somewhere, okay, and you just have Wilson as a friend, and you're trying to do some trig, you can figure this out without using a, right, and you can figure this out without using a calculator. How about that? It's pretty cool, isn't it? Now, there are, of course, situations where you don't have these special angles, and you will need a calculator. So don't get stuck on a desert island without taking your calculator. Yes, it is. You don't know that movie, Rachel? All right, here you go. This isn't so hard. So you want to find the distance. This is a bit, they got a nice pretty picture and words and stuff, and there's this guy standing 200 feet, the guy standing right here, 200 feet from a building. This is a big old building, and you want to find out how tall the building is. And he's able to figure out, he looks to the top of the building, and he sees that his angle, remember this is the angle of elevation. Do you remember that, doing that lesson? So the angle of elevation is 76 degrees. He sees the top of the building. He wants to find out how tall the building is. This is a legitimate thing that you could actually do in real life. I mean, it wouldn't be all that difficult to find your distance. Listen, it would not be that difficult to find your distance from the building to where you're standing, right? You just kind of mark it off, you know, take some steps, figure out, you know, if you take a decent step, like a pretty long step, that's usually about a yard, okay? And so you can figure out how far you're away from the building. They actually do make devices, pretty simple little devices, where you can hold it up and you can see the angle, you know, from the horizontal. Okay. Yeah, that was a weird one. Right. But on this one though, but they do make devices, very simple devices. You can find that measure. So this is a very doable measurement to find. This 200 is a very doable measurement. Now, finding how tall a building is that a very doable measurement? Would that be that easy to go to the top of the building, throw down a tape measure? Tape measure is probably not that long anyway, right? Would you agree? So it would be very difficult to find the height of the building. But in this situation right here, this is actually a way you can use trig to find out how tall that building is. And that's the cool thing about using trig. All right? So let's see what we're going to do. What do we got? We got opposite and we have adjacent. So our trig function is the tangent. So the tangent of what, though? You guys listening? The tangent of 76 is equal to opposite over adjacent. So it's d over 200. The math is easy. Multiply by 200. Now this is not one of our special triangles that we can memorize and get an exact answer. So we really could not get an exact answer for this. So I would absolutely accept a calculator answer for this. So it's 200 tangent of 76, and that is 802. And what did we just find?
The distance of the building.
Right, we found out how tall the building was, didn't we? That's a weird looking. So it's 802, is it feet? Yeah, it's feet.
We've done that kind of thing.
So I don't think your tape measure is going to go out 800 feet, is it? All right, that'd be kind of difficult to measure something like that. But there you go. Nope. Let's do another example. This is a mega lesson, isn't it? I got another right triangle. Like this. Take this long? Oh, all the lessons you mean? Oh, I don't know. It's the first lesson in the book, and I think they're just trying to capture everything. That's angle N. Alright, and they ask you to solve for angle N. So we're finding this angle right here. Let's take a look at the two sides that they give us. They give us this side 6, which is what to angle N? It's opposite. And what is the 10? You don't need the other side, though. You could to find the other side, but you're trying to find the angle.
So you just do sine of x.
So it's opposite over hypotenuse, right? So you take the sine of the angle equals what? 6 over 10. And now, how do you solve for n? How do you get n by itself? How do you get rid of the sine? Good. You take the inverse sine. How do we show that, Sammy Joe? To the negative first, right? Sine to the negative first. That means the inverse sine of 6 over 10. All right? Pretty easy, right? So you take second function sine. See how I put sine to the negative first? And then 6 divided by 10. And there you go. So it's about, we'll round it to the nearest degree. We'll say it's 37 degrees, okay? So 37 degrees, angle N. Pretty easy stuff, right? Yeah, they have a word problem. They have an angle of elevation and depression problem on there. They're both pretty straightforward. Nothing real difficult about that. I'll skip those. We kind of talked about angle of elevation a little bit right here anyway, so I think we're good. Okay, well, that's it. That's section 13.1. I'll give you a worksheet, and you can finish that for homework. All right, that's it.